Let's go. So for the video, Happy New Year, or as some people say, what's so happy about it yet? I don't know. So um, as we starting the new year here, I did extend the calendar that we had on Google Docs. So let me just show you that real quickly here, then we'll go from there. So I just wanted to see where we're at as well. So I put 1.7 there. I think that's exactly where we're at, but let's see how we finished up 1.6 and how you guys are doing. Go back through winter break here. We did do a test. Is that right? The week before we left here, I got all the grading done for the trig and calc classes, except I didn't get to you guys here. So I should get those to that today or tomorrow here. Most likely tomorrow here. But we did start 1.6. Is that right? Did we finish 1.6 before we went out for break?
I see a line that like goes like this and then shoots up, so I don't know.
Okay. And it was, we can just review it as well, but there's all the different functions we use, or at least a good amount of functions we use. It's called the library of functions. So nice. Yeah, I think we finished that one. And I did give you guys the homework sheet for all of chapter 1, is that right? So you guys should have that sheet for you with you guys. I sent a homework sheet. It looked like homework sheet for chapter 1. It should look like this right here. So it goes all the way through 1.10.
Oh, yeah.
Yeah, and then this is vocabulary concepts, and we go from there. Study guide was for the test itself, though, right? Yeah, I sent it out as well. Yeah, Okay, so 1.6 was I call them the mama and papa functions here, or the parent functions. These are the ones that are the basic functions that we do stuff with them. And so this is where we're going to start doing stuff with it. So 1.7 is called, now let's move the mama and papa functions. Because we're going to see how we can manipulate them, stretch them out, move them to the right, to the left, all the good stuff here. And then 1.8, we're going to learn how to add, subtract, multiply, divide, and then also compose functions. So there's this. With numbers, what we do with them is just add, subtract, multiply, and divide, right? But with functions, we have this extra little thing we can do called composition. 1.9 is going to be the inverse function. How do we go backwards? Can we do backwards stuff with functions? And then we got some modeling to do 1.10, and then we have a little test. And so that's kind of where we're at there, just so you guys know, have it with you. And back to this one right here. Just want to make sure that we're all started here. So 1.7 we'll do today, and then I'll see how it goes, and we'll just track out 1.8, 1.9, 110, and then a little exam after that. Are we good? Cool. Okay. There's that. And anything else that I need to mention here? Yeah, I think that's it. So let's jam to 1.7. All right, let's begin. And I'm going to show you a little chart afterwards here. So that's just my little reminder there. How's the first 4 days of the new year? At least good. Okay, you guys enjoying it? Back to school a little too soon. Back on the 4th only, or that was a quick turnaround. Okay, I think I'm going to go with this one right here, and that's right. This guy does this. So let me change things up real quickly here because it's connected to a projector. Okay, 1.7. This is called transformations. This is what they call transformation of functions. So we learned the parent function. Now we're going to learn how to move them sideways, up, down, all the good stuff here. All right, so first things first, let me give you guys all the different classifications as we're going to do them in class. We're good? And so first of all, we have something called shifts. And shift just means you're moving each individual dot to the right or to the left, up or down. So we're going to shift things over. That's what we're going to say. We're shifting things over. And so we've got 4 of them. So we have one that's called vertical shift up. And off to the side, I'm going to kind of put down what it looks like as far as function is concerned. It's going to be h of x is our new function. The old function is f of x, and then there's like a little plus c at the end. So let me give you an example first real quick here. So our parent function, let's say our parent function was x squared. Are we good? So our new function, the one we're going to be graphing, is going to be x squared plus 3. There it is. There's our little plus c value. Are we good? Abe, are we good? Okay, vertical shift up just means you have a positive c value. It's going up. We're adding 3 to it each time. So we've got a vertical shift down.
Is it always like 3 or above?
Oh yeah, it changes by what it says there. So 4, 5, or 1. Now, if you have a negative number, notice that you got a negative c value there, or a minus c value. So that means that's the one that takes you down, which kind of makes sense, right? It's the down version. Now, what does not kind of make sense at first is the horizontal shifts. Horizontal shift to the right. Now this one's the funny one because this one, these two next ones are going to. This one looks like this. In order to shift to the right, what we do is we have an x minus c inside the function. All right, and then let me show you. And we'll get to examples here. Horizontal shift to the left. And if you're shifting to the left, what you have is you're adding the c value at this time. So those are kind of backwards than you'd normally expect them. So maybe a quick example right here. It'll look something like this: x minus 4 to the second power. So that little minus 4 inside the function, but really what happened, we just shifted over to the right 4 units. Okay, so let's get my keyboard back real quickly here. All right, we're good with those. Tell me when you guys are done copying them. Okay, let me jump to this one right here, which I think, which I have set up already here. So let me get out of this. We'll come back to notes in just a little bit here. I do want to jump to, not the unit circle, that's trigonometry class, but this one is what we want to get to. So cool. Here's our x squared function. I just kind of talk about it real quick here together. So here's our x squared function. What I'm going to do is I'm going to put f of x plus 2. So you guys talk to me, and I'm going to pick on you guys here. So Isabel, what is this going to do to the original graph? Vertical shift is true. It's a vertical shift because it's outside, right? You're adding to the function itself. You're adding to the major function itself. But if it's a plus 2 on the outside, it's gonna go up, right? We're good there? Up to unit?
I saw negative.
Oh, gotcha. Okay. Thank you so much for showing that here. 1 second. Let me do a little something here. Yeah. Okay, sure. Let me do a little something. Display settings. The projector here is a little bit too old. So if I reduce this just a little bit here, it should help us to see things a lot better. And let's okay, let's jump to our graph itself. Okay, do we see a plus sign now? Yes. Are we good now? Okay, a lot better. Okay. Let's pull this down. Boom. So +2 means we're going to go up 2. Yep. Click on the dot. Voila. Love it. Now, let's have a little vote here. So question is this: are the two lines coming closer and closer together? So we're going to have a yes or no vote. So raise your hand if you say yes. Purple line and the blue line are coming together closer and closer. Raise your hand. All right. 1, 2, 3, 4, 5. 4 people? 5? Dylan's adding to the list. How many say nope, Mr. Ngiev? Nope. Those two lines are exactly a certain amount apart and they don't ever come close together. No, 0, 0?
I will.
Thank you, Camille.
You're welcome.
Okay. So here it is. Whenever we talk about functions coming closer apart, we always think about where the x-axis is. So how many units away is this right here? 2 units away, right? Because we added 2 to the function, didn't we? Okay, so let's go on to the next one. At 2, I got this one at 4, right? And this one at 6. How many units away is this? Are these two functions away from each other? Still 2 units. Is that true? Whoa, okay, at 4. Let me reach out all the way to 4. Hold on, let's go over here. Right there. Let me zoom in a little bit here. At 4, one is at, looks like 16, is that right? And one is at 18. How many units apart are they? Still 2. Wow, that's weird. So visually, because we see the whole entire graph at the same time, right? We think like, oh yeah, I could see they're getting closer to each other, right? But upon inspection at every single x, that purple graph is 2 units above the blue graph. Are we good? It's kind of like seeing a railroad tracks, right? Standing on railroad tracks, right? You see them going onward to the distance. Does it look like they're coming together? It looks like it, right? Is it true? No, they're still the same exact distance apart, right? So that's cool. Okay, back to, and Camille was right. The only person in the class that was right.
Well, that's the first.
Okay, Landon, talk to me. What's going to happen here?
Can you read out the function?
Sure, it's f of x, the function itself, -3.
Oh, it's a vertical shift down.
Vertical shift down. So this blue line should be 3 units lower, right? Now we're good there. Does that make sense? Boom. Next. Dylan. All right. Dylan, we have an x plus 4 inside the function.
Horizontal shift left.
Yeah, it's a +4, but we're gonna shift to the left because inside the function itself, we shift the opposite of what it says. And so the question is, why? Why does it do that? First things first is if we had just x squared, we would be at 0. Is that right? But here, since we have a +4, right? If 0 is included in here, you would already be at +4, right? You would be already going up 16 if you're squaring it, right? So to get back to 0, you actually have to be at -4 to get back to 0. So that's why. So it's shifting it back. It's the exact opposite of what we think. Okay. And then, Annette, all yours.
Oh, which one? Oh,
X minus 5
so these are horizontal shift, right?
to the right. So predicting where it's going to be, and voila. Are we good there? That's cool. Okay, those are shifts. That's awesome. So we're going to get to some other stuff in just a bit. Let's jam with the next stuff here. Oh, and then there, that should do what I wanted to do. Okay, next. And we'll get to some graphing in just a second here. Let me unhook my keyboard. Boom, and let's see if that's cool. And it fills up the screen here. Okay, next thing's next is something called reflections. So those are shifts. Next thing is reflections. If you think reflections, think about mirrors, right? You reflect something with a mirror. And so we have reflections, and there are only two. Reflection. So did I find a reflection? And we say in or across. Most textbooks say about the x-axis. So our new function is based upon a negative multiplying the function itself on the outside.
What's h of x?
H of x is our new function that we've made. So that's the movement that we have, whatever movement we had. So real quick here, just an example here, because this looks way, way abstract here. So how about this? Our original function is x squared. We know what that looks like, right? Just saw it. So if I were to put a new function and put a little negative in front of it. So the original function goes like this. And reflected about the x-axis. If I fold it over, take that piece and I fold it over like a pancake, it's going to be right here, true? There's my negative. So negative stuck out in front of the function itself is going to flip it across the x-axis. Next one. Reflection about the y-axis. Okay, when does that happen? All right, just like the horizontal shifts and stuff like that, it's going to happen when the negative is actually inside. So if you have a negation inside the function itself, you have a flip across the x-axis. And then the question is, Mr. G, when do we actually even have a negative inside the function? So maybe just an example here. This is a good example here, x to the third power. You're doing that. And your new function is going to be negative x to the third power. And so in this case, we have a graph that looks like this. There's my x to the third power. And if I were to reflect it along the y-axis this time, it kind of looks sort of like this. There's my little, I'm just flipping across the y-axis. Okay, so let's see. Let's do some of this. All right, let's let me go to Desmos again real quickly here. I'm gonna keep that for our notes. Let me jump to this guy again, just real quickly here. And so which one reflects that? Oh, these two right here. So number 10, boom, Charlie, all yours. Negative outside the function itself.
Reflection on the x-axis.
X-axis, boom, should look just like that. And Abe, all yours for this one.
You read it, sorry.
Oh yeah, it's F and the negative is inside the function.
It's y-axis.
Y-axis. Oh, how funny, look at this. For x squared, right, is x squared, isn't it, it's already symmetric along the y-axis? So when I do this, nothing changes right? Because it's reflected, one side reflects the other, and it's the same exact function again.
If that happens in our homework, how would we answer that? Or is that-
In the homework, if that ever happens, you're just gonna have the same exact graph. And that's it. And then we go into even and odd functions later on in mathematics, and that's what that means. So the reflection along the y-axis did not change anything. It's an even function. Okay. Whew. Maybe we should take the time. Let's do this here. Let's take the time just to graph a few of them here. So can you graph for me? We good? So we have the vertical shifts, horizontal shifts, reflection. Let's try one. So example, and then you do have to have a little graph paper, or at least make some graph paper for yourself. If you have the little quad rule notebooks, those are probably the best, because then you can make a little graph really quick and you're good to go. All right, here's my original function. Original function or parent function is x squared. Let's deal with that one here. My new function is what I want to graph. Sort of looks like this. Oh, sorry. I want to start off like this. Negative 1 squared plus 3, all yours. Let's do some shifts together here.
X minus 1 squared.
X minus 1 squared, and then plus 3. I know we used to do something for a long time. We used to have a little bit of that right there. All right, original function is x squared. That's not the one we want to graph, but we want to say, okay, I know x squared goes like this. And then there's something called critical points, which we need to sort of at least have. So 0, 0, we call that a critical point. It goes through that point. 1, 1 usually is a good critical point. And then 2, 4, because 2 squared is 4. That's those points. All right, who have we? Abe, did I pick on you already or no?
Yeah.
All right. Maddie, you talked to me. You're 0, 0. That little, we call this the vertex. Where is that point going to be located now? Or even better, yeah, go ahead. Second. Okay, let's go. Something with a 4. Okay, sounds good. Sounds good. Let me get to this right here. Let me do, how about V for vertical? And we'll do SH for shift, because we'll have a stretch in just a little bit here. So vertical stretch, and we'll go horizontal stretch. Or shift, sorry, shift. So we have a vertical shift, 3 units, is that right? And we'll go 3 units up, or up 3 units, whatever. Horizontal shift goes to the right or left? Anybody? To the right, so it's 1 to the right. So those are our little changes here, we good? So this little dot of 0, 0, which is originally here at 0, 0, we're gonna just go 3 units up, 1, 2, 3, and 1 to the right, and we have ourselves that little dot right there. Are we good? So 1, 1 is going to do the same thing here. 1, 1 originally, which just goes 1, 2, 3 up, 1 over. 2, 4 originally. 1, 2, 3, 1 over. Are we good? Dylan.
Where did you get the numbers for the vertical and horizontal shift from?
From right over here. So this 3 here, here's your vertical shift. And the vertical shift always follows the same sign. The horizontal shift is from the inside the function, and that is always opposite its sign.
So similar slope and
Kinda, yeah. The vertical shift is yes, that's for sure, because that is always going to be the same the way it works. Mhm. Okay, now for x squared, the fun little thing is it's symmetric. Is that right? So this dot and this dot, this is going to be negative 1, 1, negative 2, 4. So in this case, what we do is we just go, notice you go one to the right, one up. So we're just going to go one to the left. Whoa. There it is. We're going to go one to the left and one up. So are we okay with that dot right there? And notice for this one, we go one over and we go 1, 2, 3 up. In this case, we're going to go one more over and then 1, 2, 3 up right there. So for x squared, let me erase this stuff right here real quick here. So for x squared, we have that right there. I think that's pretty cool. So why do we do this? Why do we change functions and all that stuff? Because when you try to model, let's say, a soccer ball going up into the air, coming back down, right? You can't model it right here. You can't say, oh, it's just that function there, right? You're going to say, no, no, hold on. If we're talking about time, the soccer ball was technically on the ground, if you minus the point, right? And so it went up like this, and it came back down. So notice that's movement, right? That's, hey, you know what? That's actually a horizontal shift, is that right? Vertical shift, and then also a reflection, right? Because now it's pointing down. Soccer ball went up and came back down. Right? Or in football, it's hang time, right? Hang time is what we usually determine that to be. Okay, so let's graph these guys. Connect all the dots together and make sure it looks more like a U shape, not a V shape. Don't make this into a corner. You kind of just smooth out this little corner right here, and then you bring it back up, and you are good to go. Arrows at the end, because this guy keeps on going. Okay, talk to me. How's things with number one? Good? Just a quick little thing. Raise your hand if you say, Mr. H, I get this. Mr. H, I get this. This is easy. I got it. It was pretty cool. Raise your hand, Mr. Gio. I'm still having a little difficulty with kind of sort of a little itsy bitsy. Okay. Yeah, sure, Dylan. Good.
Well, okay, so I know that it goes 3 to the right, 3 up and 1 to the right, but like there's 1, 3 as the start, and then 4 or 2, 4 as the second point. Why is 2, 4 the second point?
And the reason for it is because when we do the origin here, these little dots right here that were the original function. Sorry, the question was, why is 2, 4 the next point? Because we take this little 1, 1 right here, and we're going to move to the right 1 unit, and then we're going to move up 3 units.
Oh, okay.
And so each one of these dots, they kind of get positioned in a different spot because of that.
Okay, so the question is based off of the graph on the left then?
Yes, So you do, yep, good question on that. You do have to know what the parent function looks like. So you do have to go back and look at 1.6 if you don't know what the parent function looks like. Got to go back and find it here. So let me do this here. I'm going to go back to 1.6 real quick here, and I'm going to just look up a function, and then I'm going to just change it up. So let's see, what are those functions that we did? Oh, I know. This is my function here. So you guys have to know what that looks like, right? In order to do it. So if you don't know, you got to go back in your notes. And then I'm going to change it up. Change it to negative on the outside. Oh man, this is so fun. +2. That's fine. Ooh, how's that for fun? That's fun. So original function is the square root of x. All right. Camille, can I bug you here? Tell me what kind of changes we have.
You can bug me, but I won't have an answer for
Okay.
you.
So let's see. First things first is that little +2 at the end. Because that little +2 at the end, we have a vertical shift. And it's 2 units up. Are we good there? That little plus thing majiggy. And then the negative sign. Anybody with the negative sign? What do we have with the negative sign? See again? Reflection, that's right. And the negative is on the outside of our function here. So I'll put REFL for reflection. And it's x-axis, you said? Yep, cool, x-axis. Okay. Boom, thanks, Abe. Anybody, can anybody give me what the original function looks like? What does this guy look like? And what are just some, like, maybe like 2 points or 3 points that are on this graph? The square root function.
On the original one, the fx equals.
Yeah, the original one, Describe it to me. And give
The
me some-
original one, like 1, 1, 4, 2.
I think so. And then one more, you got 0, 0. So 0, 0.
0, 0.
So it's the square root. So if you don't know, like, oh, I know, Mr. Andrew, I forgot what that is. Plug in some numbers into here. What's the square root of 0? 0. Square root of 1. Square root of, let's see, oh, I can't do square root of 2 because that's a square root of 4. I do 4. Square root of 4 is 2. So there's my little dots. My dots are 0, 0, 1, 1, and Dylan said, Landon said 4, 2. So my original function goes like this: 0, 0, 1, 1, 4, comma 2. Perfect. Okay, all yours. Can you usually do reflections first. Can you do the reflection first? And then move this guy up 2 units. So reflection, and if you want to draw, because some students, what they do is they'll draw actually the different dots, because this is going to get crazy after a while here. So if I get a reflection, I'm still at 0, 0, is that right? Then I'm at -1, 1, right? Then I'm 1, -1, sorry. I'm at 4, -2. But you don't connect the dots though. Don't connect the dots together. And if you have different color pins or lightly do it, that's fine too. Okay, everybody okay with my red dots on my graph? Let's shift these guys up 2 units, see where we're at. So 1, 2, there's my dot, and then make this one a little bit bigger so we know this is. So 1, 2, there's my dot there. And 1, 2, there's my dot there. And I think I'm ready now. I think I'm. So it looks something like this. It hits 0, 0, and it keeps on going this way. Okay, are we good there? Does that make sense? Charlie, making sense a little bit more? Cool. What is that anyways? That's, I was thinking, it looks like when I was at American Tire over here, it looked like stopping distance for tread on tires, but it was actually the other way. It was like this, and it goes like that. So if you have like really good tread on the tires, your stopping distance is here. And as the tread on the tires gets worn down, right, then you have longer stopping distance, right? And then they say, okay, about right here, we recommend you changing your tires because your stopping distance is a little too much. Yeah, it's kind of like the inverted one here. Huh, that's cool. Okay. Should we do another one? One more on these guys here. Exercise 3. Again, I'm going back to 1.6. I'm going to just, out of my brain, I'm going to choose a different function here. Oh yeah, I like this one too. So how about, I don't know. Everybody okay with that one? Anybody know what that one is? Which? All right, and if you need to, you can flip back to 1.6 as well, or go back in your notes to 1.6, and you should see the original function. But what are we having here? We have a vertical shift. Everybody okay there? 3 units up. Tell me, agree, disagree? We got a horizontal shift. Ooh, this is fun. Back to Isabel. Where do we go horizontally?
To the right.
2 to the right. Perfect. Okay. And then land in. Can you name the original function? The name of that guy.
Like name it like the absolute value.
Absolutely, yeah. This is the absolute value function. The graph of it goes like this, hits 0, 0 like a V shape, and it goes like that. Boom. So critical points here is 0, 0. And the fun part, it just goes 1, 1, 2, 2, 3, 3, and it keeps on going, right? It's also symmetric on the other side as well. Okay, so take 0, 0, and you're gonna go 2 to the right, 3 up, and make that little bottom point for your graph. Okay, so I'm gonna go 0, 0, which is 2 to the right, 3 up. I think I'm starting right here, is that right? That's my bottom point. That was my original 0, 0 that got changed. And for absolute value, it's kind of fun because then from here, I just know I go diagonally up from that little guy. And I go diagonally up from this little guy the other way. Boom. So there's my absolute value function being transformed. Love it. Okay, I think it's pretty cool. I think they're pretty cool. Okay, next is one more thing. One more thing we got to do, something called the stretch. Okay, now these ones are be kind of a little bit different here. And so, oh, let me get off my graph paper here. The stretching. So, vertical stretch, yeah. So this one is a students, sometimes students get a little mixed up on this one here, just for a little bit here. So vertical stretch, which means you're kind of doing Play-Doh, and you imagine that you're stretching out the y-axis. That's what you're doing here. So that happens when h of x becomes c f of x. That little c there in front is multiplying. and c is greater than 1. All right, quick example here, just kind of for us to think about here. So x squared looks like this. And if I were to say, you know what, instead of graphing x squared, I want you to graph 4x squared. Talk to me. Is this guy going to be going up very, very fast? Yeah, it's going to go up 4 times faster. So it still will start off at 0, 0. So that point hasn't changed. But instead of going up to 1, 1, now we're going up to 1, 4. So the y value gets stretched out by 4 times. So instead of going up to 2, 4, this is kind of crazy as it gets here. How about this? Instead of going to 2, 4, now we're going to all the way to 216. It's 4 times faster. So it's very, very narrow. It goes like this. It goes up very fast. Okay. Vertical shrink. That's what the book calls it. It's called vertical shrink. Vertical shrink happens when the number in front is actually between 0 and 1. So instead of it being stretched out, what happens is the y value gets shrunk down. Now we'll see those in just a bit here. Okay, I got to finish up the rest of them here. Now we got the vertical ones. Now we have the horizontal stretch. And this one's kind of a funny one. This one is inside. Okay, guys, see if we can kind of pay attention to this. Notice what happens here. Inside the function, if the number is between 0 and 1, you have a horizontal stretch. It's the exact opposite of what you would think it happens. Just like the shifting, remember that? If it's a horizontal shift, it goes the other way. Okay, last one here. Horizontal shrink. Again, the multiplier is inside. Now this time it's that much. Okay, I've got 5, 7.5 minutes left here. Let's do one. No, let's go to decimals first, and let's kind of see how that works out, and then we'll go from there. And all right. So let's go with x squared. Going up over here. Notice that little 2 right there. So for x squared, I click on here. Are we good there? Does that make sense? Instead of, so here it is. Instead of going 0, 0, 0 is good. But then if you go out to 1, 1, 1, and 1, 2, it's twice as fast. Then by the time you get to 2, you're all the way up to 16 at this point. So it becomes narrow, and imagine you're just stretching the y-axis 2 times faster. Okay, and then the fun one is this one right here. Looks like they're the same spot, doesn't it? I don't know. This one is kind of like this. You're compressing the y-axis in that value. So instead of a stretch, it's a shrink. It's a shrink for twice the shrink. Okay, let's graph them with the time left. All right, maybe let's use the absolute value function again. What example are we on?
4.
4, thank you. So original function, boom, 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 boom. And then this interesting function. Yeah, that'd be cool. So how about that? And then we'll see if I have time for one more. Okay. Cool. Absolute value. We know what that is already here. This is going to be, you guys talking horizontal or vertical? vertical. So V for vertical. And then this is a stretch. Is that right? Yeah, so ST. I'm going to do ST for stretch by 3 times. All right, original function goes like this again. Boom, boom. So 0, 0, 1, 1, 2, 2. That's fine. So what we're going to do here is we're going to take the y value and we're going to make it 3 times bigger. We good? So the x value, no change here. So 0, 0, still at 0, 0. Instead of going to 1, 1, we're going to
1, 3,
1, 3. Instead of 2, 2,
2, 6.
2, 6. Perfecto. And the other side is going to be exactly the same. So boom, boom. And now we have ourselves a absolute value going up 3 times faster. There's my absolute value. Way V-shaped now. Cool. All right, I think we have just enough time to do one more. Let's go with it. I'll let you guys finish first here. See if a couple of people still finishing up. Boom. And example 5 for the end. Okay, got to do the same. Let's do the same thing just so we don't have to mess with the differences in the functions here. So I'm going to go like this. And I'm going to go with h of x being, let's do the same one here. So that was 3, right? Yeah, this will become a little bit messy. That's okay. This will be absolute value of 3x. Now the 3 is going to be inside for us. And those are the ones that become a little bit tricky here. Okay, original function, let's see, horizontal, right? Because the multiplier is inside. Notice it's multiplying the x. So horizontal, then this we'll call it shrink, SHR. And with this one, notice on the horizontal shifts, they were opposites. These guys are going to be reciprocals now. Are we good? So original function, and getting to the end here, this is 0, 0. This will be 1, 1. This will be 2, 2. And so what we're going to do here, and actually we should get to 3, 3 here. Let's get to 3, 3. What we're going to do is we're going to multiply the x-axis by 1/3. That's what we're doing. So notice it's the reciprocal. Reciprocal. So 0, 0 still remains 0, 0. Okay, this is where the fun begins here. This is going to be 1/3 1. So 1/3 of the way to 1, we're going to have a 1. 2/3 of the way to 1, we're going to have a 1. And 3, 3. So this guy, the new one is 1/3, comma 1. This is 2/3, comma 2. Sorry. And this is going to be 1, comma 3. And the same thing on this side. So 1/3, 2/3, and 3. Okay, notice, yes, it did make the same exact graph, right? But for different reasons, right? Go from the end. We are done. Good. Cool. So that was 1.7.